Hello everyone. This is in continuation to various non-parametric tests what we are trying to understand. The next one is Kruskal-Wallis Rank Sum Test, also called H test. Here is a question. A chain of departmental stores opened 3 stores in Mumbai. The management wants to compare the sales of the 3 stores over a 6-day long promotional period. The relevant data is given below. So they gave us store A's sales, store B's sales, store C's sales like this. Use Kruskal-Wallis test to compare the equality of mean sales in all the 3 stores. So primarily we need to define the null and alternative hypothesis. Null hypothesis H0. There is no significant difference in the distribution of sales among the 3 stores. That will be our null hypothesis. Then alternative hypothesis H1. There is a significant difference in the distribution of sales among at least 2 of the 3 stores. Now we'll make this 0 and 1 as suffix. This one and H1. The next step is that we need to rank the data, means rank the data. That will be the next step, where we need to combine all the sales data and rank them from lowest to highest, handling ties if there are common ranks by averaging the ranks. So this we will be doing it in a separate Excel sheet. So let us go to the Excel sheet. So this is the same data what is given in the question. Store A's sales, store B's sales, and store C's sales. Now we will copy all the sales in the next table, in this table. And again, this below that. And then this below that. The first 6 are related to store A. Next 6 are related to store B. Next 6 are related to store C. Now we will arrange this in ascending order. So by sorting it out, smallest to largest. So we got 16 on the top. So we will be assigning rank 1, 17 rank 2, 18 rank 3, 19 rank 4. 20 is repeating twice, which means it is 5th and 6th rank are shared by these 2, which means I will allocate 5 plus 6 divided by 2, which is nothing but 5.5. So that will be 5.5. Again 5.5. 21 is also repeating twice, which means 7th and 8th rank are being shared. So 7.5, 7.5. 22, that means it will be given the next rank, which will be 9th rank. 23 10th rank, 24 11th, 25 12th, 26 13th, 27 14, 28 15, 29 is being shared between A and these two. That means 16 and 17. Average of 16 and 17 is 16.5. So 16.5, 16.5. 7 till 17 it is over. So now it is 18. So these are the ranks. So now let us copy this in our Word file. So it is being copied now. We have 1, 2, 3, 4, 5.5, 5.5, 7.5, 7.5, 9, and then 10, 11, 12, 13, 14, 15, 16.5, 18, 16.5, 2 times 18. Now we need to calculate the rank sums. For store A, so let us add those which are all related to A. 1 plus 2 plus 3 plus 4. Then we have 7.5. Then we have 16.5. These are all related to A. Let me add that. If I add, I will get 34. We are going to call that as R1. R1. Then store B. 5.5 2 times, 7.5 and 9. 5.5 2 times, 7.5 and 9. Then we have 12 and 15. So adding this 5.5 plus 5.5 plus 7.5 plus 9 plus 12 plus 15, we get 54.5. We are going to call that as R2. We copy this and modify the suffix. Then we will copy this, make it for calculate for store C. Let me do that. Store C. We have 10 plus 11. So this will be now 10. This will be now 11. Then 13 and 14. So third one, I will change it to 13. Fourth one, I'll change it to 14. Then 16.5 and then 18. 16.5 and then 18. Adding this 10 plus 11 plus 13 plus 14 plus 16.5 plus 18, we get 82.5. That we are going to call it as R2, sorry, R3. Now we will have to calculate the Kruskal-Wallis H statistic. That is the next step. So here H is equal to 12 divided by n small n into n plus 1 multiplied by summation j is equal to 1 to k. Fraction numerator or j the square divided by nj. Minus 3 times n plus 1. Sorry, we make all this, change the italics. Where this small n is equal to total number of observations. Here it is 18 observations, so it is small n is 18. Let me make this small n. Next, k is the number of groups. Here it is 3. And then rj is equal to sum of ranks of the jth group. Then nj, that is this one, nj is the number of observations in the jth group. So here it is 6 for all the groups. Every group has got same number of observations. That's why we say 6 for all the groups. J takes values from 1 to 3 because there are 3 groups. Next is calculate the squared rank sums. That is the next step. So for why we are doing this? Because here we have that rj the square for that reason. For store A, r1 square will be will be 34 the square. Thirty-four square is 1156. For store B, it will be, let me copy this and modify. $54.5 the square, and that will be 2970.25. Then for store C. It will be R3 square R3 square is 82.5 square. That will give us 6806.25. Next, divide by Nj. The sum of these values. Sorry. Divide by Nj means which is 6 for all groups. That is the next step, which means, let me copy this. This is N1, this is R1, this is N2, R2. This is 3. This is also changed to 3. So this will become 156 divided by 6. That will give you 192.67. This one will be 2970.25 divided by 6 will give you 495.04. This will give you 1134.38. Next is calculate the sum of the above values. What are we trying to do? We are trying to find out this value. Which one? This entire value. Equal to 192.67 plus 495.04 plus 1134.38. Adding these, we get 1822.09. Now we can find the H value. H value will be a fraction first. Well, divided by totally n is 18. 18 into n plus 1. 18 plus 1 multiplied by this value. Whatever we added. Minus 3 times n plus 1. 18 plus 1. That will give you 63.933 minus 57, which gives you 6.933. That is our H value. Now determine the critical value. Primarily degrees of freedom is K minus 1. K is the number of groups. Minus 1, we get 2 degrees of freedom. For alpha is equal to 0.05, means the level of significance 0.05, and degrees of freedom equal to 2, the critical value from the chi. This is following a chi-square distribution. Chi-square distribution table is, so let us verify the chi-square distribution table. This is 2 degrees of freedom. So here it is 2 degrees, 0.05. We may notice it is 5.991. 5.991. So this is 5.991. Now we can come to our inference, last step. Since the calculated H value, that is 6.933, is greater than the critical value, which is 5.991, we reject the null hypothesis. Means we will accept the alternative hypothesis. Means there is a significant difference between the sales of different stores. That will be our conclusion.